Measuring the speed of light. Observations of Jupiter's moons. Jupiter, with its many moons, has long been a subject of fascination for astronomers. In the late 17th century, 4 of these moons, Io, Europa, Ganymede, and Callisto, were visible through telescopes. During this time, Ole Roemer, a Danish astronomer, was observing the skies from northern Europe. These moons undergo eclipses as they pass through the shadow cast by Jupiter. Depending on the relative positions of Earth, Jupiter, and the Sun, these eclipses can sometimes be observed as the moons enter or leave Jupiter's shadow. For nearly half the year, however, these events cannot be seen from Earth because the Sun is positioned between Earth and Jupiter. Cassini's predictions and longitude measurement. Giovanni Cassini, the director of the Royal Observatory in Paris during Roemer's tenure in the late 1660s, published tables predicting the timing of these eclipses. These predictions provided a novel method to determine longitude. Longitude measurement relies on knowing the time difference between a specific location and a reference meridian, which in this case was Paris. By observing the timing of a moon's eclipse and comparing it to Cassini's predictions, longitude could be calculated on land. However, holding a telescope steady on a ship proved challenging, making sea-based longitude measurements impossible until the 1730s. It was then that John Harrison introduced marine chronometers, clocks that could keep accurate time at sea. Ole Rømer discovery of light's finite speed. Rømer meticulously studied the eclipses of Jupiter's moon Io over 2 years, comparing his observations to Cassini's tables. He noted an 11-minute discrepancy in observations when Earth was closest to Jupiter compared to when it was farthest away. This discrepancy could not be explained by known orbital irregularities of Earth, Jupiter, or Io. Instead, it represented the time light took to travel across Earth's orbit. Using the diameter of Earth's orbit, Roemer was able to calculate the speed of light, arriving at a figure of 133,000 miles per second, 214,000 kilometers per second. While this was about 25% lower than the current accepted value of 186,282 miles per second, 299,792 kilometers per second, it was nevertheless an impressive first approximation and demonstrated that light had a finite speed. Reception and further confirmations. In England, Isaac Newton supported Roemer's hypothesis that light did not travel instantaneously. However, not all contemporaries agreed with Roemer's conclusions. Cassini, for instance, noted that discrepancies in observations of the other moons were yet to be explained. Roemer's findings gained broader acceptance only after English astronomer James Bradley provided a more accurate measurement of the speed of light in 1729 through his work on stellar parallax. Roemer's pioneering work was a critical step in understanding the nature of light and laid the foundation for future discoveries in the realm of physics and astronomy. Thanks for watching the video, and don't forget to subscribe.